further outcome of the quantification of performance program sees the introduction of another verification method to address performance requirements FP 1.4 of Volume 1 and P 2.22 of Volume 2, dealing with weatherproofing of external walls. Verification methods in the NCC, as we discussed earlier, are provided to assist in demonstrating compliance with the performance requirements. They're not mandatory components of the NCC, however they are one form of assessment method which can be used to demonstrate compliance. Water penetration through the external envelope has proven to be a major problem for countries such as New Zealand and Canada, and there is evidence that it's becoming a problem in Australia. To address this issue, a new waterproofing verification method FV1 and V2.2.1 has been produced. So let's look and see how it works. In using verification method FV1 and V2.2.1, a risk score is required to be calculated. A risk score of 20 or less must be achieved in order to use the verification method. A risk score over 20 is deemed outside the scope of the verification method. A risk score is calculated by using table FV 1.1, which requires the following deemed risks to be taken into account: wind region, number of stories, type of roof, wall junctions, eave widths, complexity of the building envelope, and types of decks and balconies. Now, before you say all of that doesn't add up to 20, this is only an extract of the table. The table has actually got a few more pages to go to it. Once a risk score has been determined and the verification method is deemed applicable for use, a test procedure must be undertaken on a representative specimen of the wall type. There are three wall types: direct fixed cladding, cavity wall, and unique wall. All three are described by a defined term, so we'll have a look at each type of wall. Direct fixed cladding means a wall with cladding attached directly to the wall framing without the use of a drained cavity. For example, a direct fixed wall might be cladding such as weatherboards or sheet materials attached directly to the building structural framing. Cavity wall means a wall that incorporates a drained cavity. The required cavity consists of a clear, unobstructed space or cavity, or cavity battens. For example, a cavity wall might be your typical masonry veneer, of course. It may also consist of battens and cladding attached to the external face of a framing, provided it can be demonstrated that the water does not pool on the battens or any other cavity surface. The unique wall means a wall which is neither a cavity wall nor a direct fixed cladding wall. This includes, but is not limited to, a single skin walls which provide not only the outer weather protection but also act as the internal wall that may provide structural components. An example of such walls could be a concrete tilt panel, single skin masonry, or a glass curtain wall. Clause B of the verification method describes the various elements and components that must be included in the test specimen. You'll note that there is a specific requirement for a section of transparent internal wall lining for a cavity wall to effectively sight any water penetration. The elements and components of the test specimen are illustrated here by figure VF1-2 from the guide. So some of the elements include vertical and horizontal control joints, wall junctions, windows and doors, electrical boxes, balcony drainage and parapet flashing, and header and footer termination systems. The test specimen must be subjected to a test procedure. There is one procedure for a cavity wall and another procedure if it's a direct fixed cladding or a unique wall. Both procedures require the application of a cyclic test in compliance with AS NZS 4284/2008, Testing of Building Facades, which is a new reference document in the BCA. So we'll have a closer look at a testing station located in Australia that recently carried out some testing on a proposed ACC panel. So if you have a look at the slide on the left, you'll notice that shows the framework set up. It's got the battens coming in, it's got the window frames, door frames, the electrical box you'll see up there, and the inside cladding, and it's transparent, so if there is any water penetration during the test they can see through. On the drawing on the right, you've got the finished surface of the external cladding, the finishes around the windows and doors, and if there's any expansion joints they'll have, however they're finished. I think you can just see a little line at the bottom of the door there. And directly opposite that is your spray nozzles and your wind, where the wind and water pressure is then applied to that external face of the wall. To assist practitioners in using and interpreting the new verification method, wording and diagrams as such previously highlighted has been added to the guide. Furthermore, the ABCB has produced an advisory note which is downloadable from the ABCB website. In NCC 2014, Volume 1 removed Section I, the maintenance provisions, from the NCC because that was considered a state and territory regulatory function. JP2 is a qualitative performance requirement that requires access for maintenance of energy efficiency measures. Similar to the previous Section I, provisions, this is considered a performance requirement solely related to maintenance, and consequently, the performance requirement JP2, along with the associated DTS provisions of J8, have been removed from BCA 2015. National workplace health and safety legislation includes a primary duty of care regarding persons conducting a business, so far as it's reasonably practical to ensure the health and safety of workers and others who may be affected by the carrying out of work. These workplaces are required to provide to be safe, and that would include the provisions of safe maintenance. Therefore, the requirements covering safe access for maintenance are covered by the relevant workplace health and safety legislation. Safe Work Australia have published a code of practice on safe design of structures, which covers safe design, specifically dealing with the design for safe maintenance. In addition, supportive guidance such as maintenance and operation of HVAC systems for energy efficiency, produced under the National Strategy on Energy Efficiency, or NESE, are considered to be more appropriate mechanisms for this matter than in the BCA. In conclusion, immaterial of where the legislative mechanisms for maintenance access is located, it is evidently obvious that there is a practical need to ensure proper consideration is given to the access of maintenance in any building design. To reflect this understanding, an amendment has been made to A2.1, reminding designers and regulators to consider this aspect of building design. The next selection of slides will now cover changes to the energy efficiency provisions of the BCA. The BCA contains requirements in Section J and Part 3.12 for the insulation of floors containing in-slab heating or cooling systems to limit heat loss or gain. Within the insulation requirements for floors containing these systems, additional explanatory information were contained in both the guide and Volume 2, stating that an under-tile or in-screed heating system in a bathroom, amenity area or the like, is not considered to be an in-slab heating system. This exclusion, provided in the non-regulatory guidance and explanation information, when combined with the current language of the DTS provisions, created confusion as to the intent and application of the requirements. Consideration was given to the need for the application of energy efficiency requirements to in-screed heating or cooling systems, and it was determined that these energy efficiency requirements do apply. If you have in-screed heating or cooling, the building floor needs to be provided with perimeter insulation, the same as for a normal in-slab heating. The exception to this is where it only applies to small areas such as a bathroom or an amenity area. Concerns raised by industry indicated that provisions of Part J5 are sometimes difficult to comprehend and apply, and the level of performance required in some areas was questioned. To address these concerns, a project was undertaken in 2013 and 14 by the ABCB to review Part J5 with an overall aim of improving and simplifying the provisions to assist in achieving greater levels of compliance. Part J5 has now been restructured along with some technical changes in BCA 2015. Firstly, an amendment to the defined term air conditioning has been made to exempt air conditioning systems where the primary purpose of the system is to serve equipment or processes such as cold storage rooms, as shown on the slide, or computer data storage rooms. An increase of the fan motor power allowance for car park ventilation systems has been allowed as the current power allowances in some circumstances were too low and unachievable. A good example of the changes made to Part J5 is Specification J5.2C, describing the insulation requirements for water piping. As previously mentioned, there are a number of new specifications included in the restructure of Part J5. One of these, Specification J5.2C, replaces the old specification J5.4, which describes the minimum insulation requirements for piping, vessels, heat exchangers and tanks. The previous Table 2A of Specification J5.2C that described these requirements was based on the capacity of the system and contained an unnecessary wide range of R values applicable to the relevant capacity of the system, the location of the pipe and the climate zone. It also included some confusing terms such as cooling water. All in all, the BCA 2014 provision were considered to have a level of complexity inappropriate to the intended outcomes. The new specification J5.2C Table A now simply refers to the nominal pipe sizing subject to the insulation to determine the insulation level rather than refer to the capacity of the system. This approach has reduced the range of R values to easily identifiable and workable range that assists in demonstrating on-site compliance. To further assist, some guidance is given in the guide of what piping materials and associated thicknesses may achieve the insulation values contained in Table 2A. The targeting piping that is subject to insulation has been clarified by replacing the confusing term cooling water with the more correct terminology chilled water. A further change to Table 2A is the introduction of an insulation concession for higher range temperature chilled water piping to recognise the smaller energy savings that can be achieved by insulating this category of water piping. Overall, the simplification of Table 2A has resulted in the reduction of the required compliance parameters from 45 to now just 4. A significant amount of additional information has been added to the guide to help provide assistance in the interpretation of Part J5 provisions. Guidance on all the items that have been addressed on Part J5 review are reflected in the guide. Concerns have been expressed to the ABCB about the impact of roof solar absorptance and its contribution to roof insulation and thermal performance. Based on research undertaken, adjustments have been made to the required total R values for roofs and ceilings in Table 3.12.1.1a to better reflect the benefits of light-coloured roofs and improve alignment with the NATA's software. A change has been made to 3.12.5.1 to align the R values in this table with the methodology in the reference document ASNZS 4859.1/2002, Materials for Thermal Insulation of Buildings. The R values are those for the insulation and not the total R values of the pipe, air film and insulation. The supporting information provided in the explanatory information related to Table 3.12.5.1 was also changed to reflect the methodology in ASNZS 4859, providing examples for the R values used for piping insulation of a smaller diameter. Given that the R value in the table and the explanatory information have been changed in a consistent manner, no change to the stringency has been made. An amendment to 3.7.1.7c sees the addition of an explanatory note, brings further clarification to what are allowable encroachments for the purpose of fire separation. The change is intended to remove any misinterpretations of the term unroofed terrace. A deck is not considered an unroofed terrace and is therefore not permitted as an allowable encroachment under 3.7.1.7b, whether it's combustible or not. There has been no changes to the provisions, only clarification of what was the understood intent, and that was that adjoining decks to boundaries with their higher fire risk by association with a direct connect to openings in the house, sliding doors, etc., along with the potential to have a neighbour's deck directly connecting to the allotment boundary and consequently enhancing the fire risk, which could allow a high fire burn back into the adjoining house, either through combustible materials and coverings or through subfloor pathways created by the adjoining decks, and not the intent of Part 3.7. And it has now been clarified by the change in the explanatory information. Clarification has also been provided in the explanatory information that a pergola is a reference to an unroofed structure. An amendment to 3.8.2.2f makes it clear that a minimum height of 2 metres will now apply to all landings, ramps and stairways. This change now aligns the provisions with the current requirements of F3.1.